This is the written practice for lesson 4, which is on multiplication and division word problems. So the thing to remember is that our plot for multiplication and division word problems is that you have the number of groups times the number in each group and that equals the total. So we have the number of groups times the number in each group equals the total, and the way that the book abbreviated that is N times G equals T. So that's something handy maybe to put at the top of each page as we go through it so that you can refer back to it. The band marched in 14 rows with an equal number of members in each row. If there were 98 members in the band, how many members were in each row? So we're going to use our equation here. So the number of groups corresponds to the number of rows. And then an equal number in each group. We're not sure how many, but we do know that the total is 98. So two ways that you can do this are count by 14s up to 98, or the book said that when you're trying to solve for one of the factors, you take the total and divide it by the known factor. So we could take 98 and divide it by 14. So 14, 28 is 2 14s, 2 28s is 56, and another 28 gives me 84, and one more 14 gives me 98. So that's 7 groups. So 98 divided by 14 is 7. You can see 7 times 10 would be 70, 7 times 4 would be 28, 70 and 28 is 98. So 7 members in each row. Olga bought 5 cartons of 1 dozen eggs. How many eggs did she buy? So we have the number of groups, 5 cartons. We have how many are in each group, and we want to know how many total did she buy. So N is 5 cartons times 1 dozen eggs each, which, since we're asking how many eggs, I would turn dozen into 12. A dozen means 12. So 5 cartons, 12 eggs in each. How many is that? Again, we're working with not reaching for the calculator instantly every time we need to do a small calculation like this. So I can break 12 into 10 plus 2, which then turns into 5 times 10 plus 5 times 2. 5 times 10 is 50. 5 times 2 is 10. So 5 times 12 is 60. So she bought 60 eggs. Alright, so number 3 says the 5-kilometer, which is 5,000 meters, hiking trail will have markers placed every 800 meters. How many markers will be used? Explain why your answer is reasonable. So we have the total distance 5 kilometers or 5,000 miles. We have how many meters will be in each grouping, 800. We want to know how many groups or how many markers there will be. So we don't know n, and then times 800 meters. Now, since I have meters on my units here, I need to use the total one that matches that same units. So I need to have the 5,000 meters instead of just the 5 kilometers. So this I would look at and I would say, all right, I have 8 and I have 50, and then I can kind of ignore the 2 zeros at the end. So what times 8 gets me close to 50? Well, 6 times 8 is 48, so I think that's about as close as I can get. So then I look and I say, okay, how many zeros do I want my end one to have? I want it to have 3, and right now I only have 2. So I'm going to have 60. N equals 60 markers. And then it asks me to say why my answer is reasonable. So you could say, well, 800 is kind of close to 1,000, and if we did a marker every 1,000, we'd have 5, but we're going to have more since it's every 800 instead of 1,000. You could say, well, 800 is somewhere between 500 and 1,000. If we did it every 500, we'd have 100 markers, but we're going to have less than that since it's 800. So all of those explanations would tell you that your answer is reasonable, and it's really important to make sure in the end if your answer is reasonable. You don't want to just believe what a calculator says, because they don't know the problem like you do. Fadi bought 3 pounds of apples at $1.98 per pound. So we have how many groups? 3 pounds, and we have the number, and in this case price, per group, or the number in the group. So we're going to have N3 times G 198 equals the total cost. So now we're going to look and see what we have as options for the multiple choice. We want one to look similar to this one, which rules out these because they have the variable with something else. And then we want the variable being multiplied. So we're going to go with B. Number 5 says there are a total of 200 students and chaperones going on a field trip. Each bus can hold 60 passengers. How many buses will be used for the trip? So we have 200 total, and we have 60 in each group. We need to know N. So N times 60 equals 200. So if we count by 60s, we want to get close to 200. In fact, we either have to hit 200 exactly or go over, because otherwise people would get left behind. So 60 plus 60 is 120, plus 60 is 180. So if we only got 3 buses, then 20 people would be left behind, which you'd be kind of bummed if you were left behind. So if we add another 60 onto 280, then that gives us, onto 180, that gives us 240, which is enough room. So we need 4 buses. The other way that you could do that, it says in the book that when you are looking for a factor, you take the product or the total and you divide it by the known factor. So if I do 200 divided by 60, then I'm going to get 3. 3 times 60 is 180. And I'd have 20 people left over is what that would tell me. and then I would know I'd need another bus to fit the 20 people on. And then explain why your answer is reasonable. If you thought of 50 passengers on each bus, and the buses you need to fit 200 people on, 50 goes into 200 5 times, so that would be, or excuse me, 4 times, that would be reasonable, because that's about the answer we got. So you need 4 buses. On Lee's first attempt at the long jump, she jumped 297 centimeters. On her second attempt, she jumped 306 centimeters. How much farther was her second mark than her first mark? So now we've switched gears and we've gone back to review some of what we did in lesson 3. So if you look at this one, they're asking us to compare her second and her first jump. So the plot for this one is comparing. And when we compare, we take the greater, which is 306 centimeters, minus the lesser, which is 297 centimeters, and that gives us the difference. Well, 297, 3 more gets me up to 300, and then 6 more gets me to 306. So 3 plus 6 is 9. So her second mark was 9 centimeters more than her first. Zoe, Ella, and May ate lunch at the deli. The cost of Zoe's meal was 8, Ella's was 9, and May's was 7. What was the total of their bill before tax? So, this one they're asking us to put all of those costs together. That's a combining problem. That's the combining plot, excuse me. And when we're combining, we take sum plus more, and in this case, plus more still, and that gives us the total. So we have sum, Zoe's meal, plus more, Ella's meal, plus more, May's meal. So 8 plus 9 is 17, plus 7 is $24. Aaron was awake for 14 hours. He spent 6 of these hours at school. For how many hours, or for how many Aaron's wakeful hours was he not at school? So in this one, you're talking about separating. So 14 total hours. He spent some of them at school, so it's kind of like taking those away. We want to know what's left of his awake time. So we're talking about separating. So we have the starting amount, 14 total hours that he's awake, minus some that went away, 6 was spent at school. That equals the difference. And in this case, 14 minus 6 is 8 hours. So he spent 8 hours not at school. Number 9 asks us to write a word problem for this equation. We have $5 minus P equals 150. So we could say that Joanne went to the movies and bought popcorn, popcorn. She handed the clerk a $5 bill and got $1.50 in change. How much did the popcorn cost? So we can see this is a separating problem. You started with $5. She spent some on popcorn. This is what's left. And we could go back and find out that popcorn must have cost $3.50. You know, movies and popcorn are expensive. Then it says, write a word problem for this equation. So you could say, this is a equal groups equation, and one of the examples that they kept using was one about tickets. So you could say, the total cost for tickets to Valley Fair for a group of students was $125. If tickets cost $25 each, how many students went to Valley Fair? Okay, so you can see if we were to multiply the number of students, which is the unknown here, by the cost of the tickets, each $25, we would get 125. If you solved it, you'd find out that there were 5 students that went on the trip. Arrange these numbers from least to greatest. Well, I'm going to look for the most negative number, -4. Then the next most negative number, -3, -1, and then the smallest positive number, 2, and then the largest positive number is 5. Comparing, the most negative number is the smallest. So remember, the alligator eats the bigger number, so this side of the less than or equal or greater than symbol needs to be on the side of the bigger number. Comparing a positive versus a negative number, the negative number is going to be the one that's smaller every time. Now we're looking at absolute value, which remember is how far they are away from 0. So -7 is 7 places away from 0. -8 is 8 places away from 0. So now comparing 7 and 8, 8 is the bigger number. Absolute value again, 11 is 11 spaces away from 0. -11 is also 11 spaces away from 0. So these two are equal. Name 2 numbers that are 7 units away from 0 on a number line. So if I have 0 here, 1, 2, 3, 4, 5, 6, 7 over here would be a positive 7. 1, 2, 3, 4, 5, 6, 7 the other way is -7. So both of those are 7 places away from 0, so they both would have an absolute value of 7. So my options are 7 and -7. Which 2 integer values for n make this equation true? So if I want the absolute value, which again, remember means how far away from 0 are they, to be 1, I have 2 options. It's really similar to the question that we just did. So I want the distance from 0 to be 1. Well, I can either go to the right or to the left of 0. So n can be 1 or -1. Number 16, I was a little bit confused on at first. Had to look up the answer so I can help you out. It says use braces, and braces are the fancy brackets, parentheses, that are squiggly, and digits to indicate the set of odd numbers. So we're going to start with a brace, and it's going to go continue on from the first number that we write, because it's a set, it continues on infinitely. So I'm going to give them some examples like -3, -1, and then going into the positives, 1, 3, and so on. The dots mean that they keep on going. And then it asks us to graph that as well. So if we get a number line, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So we would put down here 5, -3, -1, 1, 3, and 5. It says refer to the expressions to answer the questions that follow. So 6 times 5 equals 30, 12 divided by 3, or 12 over 3 equals 4. So things that are being multiplied are the factors, 6 and 5 are those. Which number is the quotient? The quotient is your answer in the division problem, so that's 4. Refer to these expressions to answer the questions that follow. 3 plus 5 equals 8, 17 minus 7 equals 10. Which number is the sum? Well, a sum is your answer in an addition problem, so that's 8. Which number is the difference? Well, the difference is the answer in a subtraction problem, so that's 10. In number 20, it says consider the following: 3 plus 28 plus 17. How can the numbers in the expression be arranged to make the addition easier? Well, when I see 3, I'm hoping that there's going to be a 7 to pair with it, because that's going to make 10, and even 10. Well, in this case, 20. 3 plus 17 will be 20. So I'm going to rearrange it and do that first, so that then I have something that ends in 0 to add onto it. So I would rewrite it as 3 plus 17, and then parentheses around it to tell me to do it first, plus 28. Which properties did I use? Well, when I reordered it as 3 plus 17 plus 28, that was the commutative property, which says that I can put things that are being added together in any order and it won't change the answer. Then when I grouped them as 3 plus 17 plus 28, that was the associative property, which says I can put parentheses to group them. And that also won't change the answer. Then we have simplify and compare. 12 minus 5 is 7. 5 minus 12 is -7. And then 7 is greater than -7. Number 22, if 3 times 21, 3 times 7 is 21, what other multiplication fact and what 2 division facts are true for 3, 7, and 21? So we reorder the 3 and the 7, and we come up with 7 times 3 equals 21. And then we can divide the product by one of the factors. So 21 divided by 3 equals 7. 21 divided by 7 equals 3. If 2 plus 4 equals 6, then what other addition fact and what two subtraction facts are true for 2, 4, and 6? So we reorder the 4 and the 2. So 4 plus 2 equals 6. And then we can subtract the addends from the sum. So we can have 6 minus 4 gives us 2, and 6 minus 2 gives us 4. What number is the opposite of 10? Well, opposite means the opposite sign. So right now I'm a positive 10, so I could have negative 10. Which is greater? Which is the greater total? 4 groups of 20 or 5 groups of 15? Well, 4 groups of 20 means 4 times 20, which is 80. 5 groups of 15 means 5 times 15. And we have 5 times 10 plus 5 times 5. If I break up that 15. And that gives me 50 plus 25, which is 75. So the greater total is 4 groups of 20. Which change in height is greater, 54 inches to 63 inches, or 48 inches to 59 inches? This is a comparing problem, so we're going to take the bigger minus the lesser. 63 minus 54 gives us 9. And then we'll take the bigger of the other ones. 59 minus 48 is 11. So the 48 to 59 is the larger difference. 27. Which total cost is less? 25 tickets for $5 each or 20 tickets for $6 each? So 25 tickets times $5 each gives me, well, 4 25s is 100, and one more 25 gives me 125. And then 20 tickets times $6, 6 times 2 is 12, and then I just add the 0 from 20. So $6 tickets for 20 of them is cheaper or costs less than buying 25 tickets at $5 each. Use braces and digits to indicate the whole set of numbers, or the set of whole numbers, excuse me. So again, we're using the squiggly brackets. Whole numbers start at 0. They don't include the negative numbers. And then they go on 1, 2, 3, and the dots means they keep going like that. And the next one, it says, consider the sets of integers, and integers, remember, is whole numbers and negative whole numbers, and counting numbers. Which set includes the whole numbers? Well, counting numbers, you don't start with 0, you start with 1. So we have to use the integers. Integers will include 0 and then positive 1, 2, 3, 4. So the integers include whole numbers. So 0 isn't a counting number, but it is a whole number and an integer. And the final problem, which two numbers satisfy this equation? So we're talking about absolute value. So how far away from 0 would it be? Well, I can go a half slot away from 0 to the right, or a half slot away from 0 to the left. So if this was positive 1 and this was negative 1, I could go halfway to the left. That would be negative 1/2. Or I could go halfway to the right. That would be positive 1/2.